Hello everybody, welcome to the second lecture of Modern Database Concepts. My name is Johannes Schildgen, but I think that's something you already know. Today we will look at semi-structured data. So are you there? Can you hear me? Write something in the chat and write in the chat any questions that you have during the lecture. So semi-structured data. Before we look at semi-structured data, I bring this term in the context. It belongs to the classification of data in general. This is not complete, but this is a classification of data as it's often done. There are also other kinds of data, multimedia data like images, videos, PowerPoint presentations and so on. So an image is actually not a multimedia data, it's a media data. Multimedia means many media. For example, a video consists of images and audio and further information like subtitles or metadata and so on for describing the video. We will not look at multimedia data today. We will take a look at structured data, semi-structured data, and unstructured data. So, structured data is the very easy to interpret one. That's the data that you know from SQL. From relational databases. You have a fixed schema, you define the attributes that your data will have in advance, and then your data must match this schema. That's structured data. The data follows a specific structure. Semi-structured data, the data follows a structure, but this structure is contained in the data itself. So that's what we do today. We look at data formats like here JSON, where the data contains the metadata. The metadata is part of the data itself. Here for structured data, this is not the case. Here we have the metadata on top, that's the column descriptions in this case. And the data, these are the instances, the values. They can be seen separately than the metadata. But here, the metadata is part of the data itself. When you load a JSON file, the metadata, the attribute names are part of the JSON file itself. And that makes it flexible. So other documents can have other attributes, and this makes it maybe in one dimension a bit easier because you have everything together. You don't have to care about the schema beforehand and then load the data. No, you have everything together now. And to complete this picture, there's also unstructured data. Unstructured data is becoming very popular in the social web, the social networks and so on. So data that is generated by people in social networks, for example, Twitter. This is text. Text is written by people. Text is hard to understand. Texts have different languages, German, English, Japanese, and so on. People make typos within text, so it is hard for an algorithm to decide what to extract out of a text. Is it true what is written there? Is it false? When somebody writes it in a text, what does it relate on? So let's say Susan's daughter is named Maria. She is 10 years old? Who is 10 years old? Susan or Maria? We know, okay, the mother cannot be 10 years old. But this is very hard to interpret when you don't have a structure in the data. Unstructured data is just text. Unstructured data can also be an image data. There you have the color pixels of an image. Or audio data. Yeah, for an audio, which is, for example, spoken audio, you first have to translate this with speech recognition techniques, voice to text or speech to text, to have a text, and then do the same algorithms as you do on text. But then again, more errors can occur during this speech recognition. We will focus today on semi-structured data. This is something you already know. Structured data has a fixed structure and not so many challenges like the others. And unstructured data has a lot of challenges, but we will not do this in this lecture here today. This is something you can learn when you focus on natural language processing, on data mining, and so on. So, one question. Please go to frage.de with double A. Frage.de, and please give me the answer to the question, what is the difference between structured and semi-structured data? Is structured data harder to work with? For structured data, a schema has to be defined in advance. Structured data has metadata, semi-structured has no metadata, and structured data is more flexible. So only one fact is true. Please click on the true one here. Let's take a look on the live stream. We have 59 people currently watching. Let's say when 50 people answered, I will count to 10 and then I show you the solution. I think the most know the answer because I said it multiple times, and for most of you I think this is not so new. I think most of you already heard about this difference so far. If you have never heard of the difference between structured, semi-structured and unstructured data, please write it in the chat. By the way, there's another chat I opened. So if you don't have a Google account, you can open a chat in the Crips system, and you can ask questions there. So if you don't have a Google account, then ask in the Crips chat. If you have a Google account, then ask there, and I will read out the questions loud that are written in the Crips chat. Okay, 58 people answered. Of course, for structured data, a schema has to be defined in advance. Some people said structured data has metadata. Semi-structured data hasn't. Semi-structured data also has metadata, product ID, description, price, but here the metadata is part of the data itself. Here it is kind of separated, here it's part of the data itself. So semi-structured data has metadata. Basically all data has metadata. This unstructured data has metadata about the encoding. Is it UTF-8 or is it using an ASCII encoding? So yeah, all data has some kind of metadata. Metadata means data that describes the data that helps me and the computer understanding what the data is about. This metadata helps me answering the question, what 17? Does it cost 17 euro? No, the product ID is 17. Here the same. What's this? Ah, this is the price. Okay. Okay, that's about the chat. Let's continue with some examples. We will look at not all of them, but we will look at all of them. We'll look at all kinds of semi-structured data formats here. Basically, this is not comparable with the other data formats, but I listed it here because comma-separated values, CSV files, or CSV in general, in most cases it is used for files, is very popular. And if you have never seen CSV, then I will give you an example. CSV means comma-separated values, so you separate values by commas, and then in each line of that file you write one data item. So this is a data item, a product. The product has a product number 17, it is called chocolate bar and costs 89 cents. And in the next row you have the next product. This is very good for importing and exporting data from relational databases or other systems. Many systems offer an import and export for CSV. You can even open this CSV file in Microsoft Excel or so, and work with it like an Excel table, and you can export Excel tables as a CSV file. Then we will look at YAML. YAML is very interesting. It is quite new. It's also a very simple format. It means YAML ain't markup language. YAML. And XML is a very prominent or the most prominent format for semi-structured data. I think when you Google semi-structured data, then you will first find XML. That's the most popular XML format, the most popular format for semi-structured data. But people say it is kind of dead. JSON is the new way how to do it, but it is not dead. XML is used, for example, for Office formats. When you store Microsoft Office files, it is internally stored as an XML file. When you understand XML, you understand working with HTML better for websites. This video here that you're currently looking, this stream has a thumbnail, a little picture, and actually this picture shows HTML. HTML looks like this. It is similar to XML. There are some differences. You could say this is a special form of XML, but this is not so strict as SQL. For example, here is a line break. BR is a line break. This means I want to make a new line on this website. And this is something that is never closed. In XML, you have to close everything that you open. Here a section begins and here a section ends. Here the same. Here's an image. The logo of the OTH is shown here. And this image does not close. You can close this with a slash character immediately here, but the HTML format does not force you to close everything that you open. There's another format called XHTML. this is similar to HTML, but it follows the XML rules. So everything that's opened has also be closed. So we will take a look at XML formats. For example, when you want to store products in an XML file, you can have entries like product ID 17 is the chocolate bar, then you open price and you close price, and in between you write the price, and then the product is finished. It's hard to read and it's complex. What do you mean? This one here. Or did you mean that XML is dead because it's hard to read and it's complex? XML in general. Yeah, you are absolutely right. Yeah, it's not mainly used for humans. So one goal of inventing the language was that humans can understand it. So it's different than Afro or so, data formats which are only for the machine. But so humans should understand it, but that was not the most important thing. But yes, you have a lot of redundancy here. Here you have to say product when you open that element. Here you have to write product to close it again, and so on. And JSON is much simpler. So it's absolutely true that this is a benefit of JSON, to have much simpler notations there. It should be readable, but also easy for computers to work with. Then we have a question here from the chat. I load it like this. That's actually because the browsers are forgiving when parsing HTML, isn't it? In theory, that is invalid HTML. No. I said in HTML, you have elements that do not close. And I make it bigger here. So we will learn XML. XML has rules. Everything that has to open has to close. And XHTML is a special form of XML. That means it is a valid, a well-formed XML document. And let me remove this question here. And it has specific elements. P for paragraphs, LI for list items, and so on. So XHTML is a well-formed XML document. HTML is not necessarily a valid and well-formed XML document. I have to be careful with the word valid and well-formed. Well-formed means, we come to this later, that it follows the rules that the language has. So every element that opens is closed. And both have its origin in a language called what was it? Is it SDML? I'm not sure. Nobody uses this. Let me take a look. SGML. So XML and HTML are not father and daughter, but they are brothers and sisters. So that's the thing to answer your question. So it is valid HTML to not close a BR command. So here you are allowed to make a line break and not close this line break. and here you have to open everything that you have to close everything that you open. So I had to take a look. XML used SGML, Standard Generalized Markup Language, 1986. Yeah, the people always say, Johannes, the lecture is called Modern Database Concept. Why do you talk about XML? In my opinion, you are a better developer and you can better work with JSON and data formats that are up to date, that are modern, that are 2021, when you understand the way the languages get there where they are. So in 100 years, computer science will look differently than today. And today, computer science is different than 20 years ago. 20 years ago, in the year 2000, XML was very prominent. People thought that XML databases will be becoming the main kind of databases. No. Okay, CSVs, comma separated values. So one good thing, so do not repeat the mistakes of the past. Yeah, of course. You should learn as much as possible to learn for yourself what was good and what was not so good. But XML was not bad. That's not true. And in many companies, XML is still used, and XML is a file format that you might see in the future, and XML is not dead. And what I wanted to say, the reason why I teach XML to you is XML has concepts like flower expressions in the language xQuery. And these flower expressions have an influence to programming languages and query languages, not programming languages, but query languages. And XML has a XML schema, and there's a JSON schema as well, which is similar to that. So you understand the modern concepts better when you know the origins of that. CSV, comma separated values. What we often have is a header row. So this first row here does not contain data, it contains the metadata. There is not the CSV standard, but there are some ISO documents that say how CSV files should look like and what the CSV format should so it is somehow specified, but it's not the standard like the XML standard or the SQL standard. So we have a header row. It is also possible to have XML files without a header row. So let me go back to the text editor here. I write that XML a CSV document in a text document, products.csv, and now I can use my file browser to open product.csv in an Excel. Yeah, if I would open it in LibreOffice, LibreOffice would ask me, hey, what are the columns? What is the column delimiter? Sorry that my PC is in German, but does each column have a fixed number of characters? These are FBV files then, fixed block value. So then you say the first 10 characters is the product ID, then the next 100 characters is the description. This is also a valid format, but for CSV, the S stands for separated, so getrennt means separated, and I select the column separator. In my case, the column separator is a comma. For other files, it's also possible to use a tab or a semicolon or something else as a column separator. And now it is loaded, imported into LibreOffice Calc. It recognizes it as a table with 3 columns. And now I can edit it, save it again, and it saves it again. In Excel and VPS Office, it always uses the tab as the column delimiter and as my the column separator. And as my column separator is not a tab character but a comma, I have to manually do data text to columns, and I say again it's still limited. Now my VPS Office is in English, so it gives me a preview, and then it is displayed here as well. And this is how you import CSV files in Excel, text to columns. So when you have here 4, 5, 6 and you say text to columns delimited by a comma, it is this feature here. And for other tools, it's similar. When you want to import data into a relational database, you can use dbeaver, select a table. Oh, here is a table called Corona, and I say import data, CSV file, and then you select a file, and you also specify what's the column separator, it's a comma, what's the encoding, does it have a header row at the top or at the bottom, and then dbeaver, this is a universal database client, we will use this later in a few weeks for working with relational databases. dbeaver can import CSV files into tables. So the properties of this CSV file here is we have a column separator, comma, a column delimiter. This character is used when you need the comma, your column separator, in the string of the column itself. So here we have dishwasher tabs, comma, 100 pack. So we need the comma, and if we would simply write a comma here, it would say this is the value of the first column, this of the second column, and this of the third, and this of the fourth column. But basically we don't have 4 columns. So when you need the column separator, you have to write the full column value into double quotes. And the double quote is the default column delimiter. You can also change this. You can say my column separator is a semicolon and the column delimiter is a pipe character, or what else. So this is not standardized. You can configure this as you want. And when you need the column delimiter within a value, you have to double it. So it's a double quote. Header row, yes, it is here. Other files don't have header rows. And the encoding, yeah, it's important for the program that imports this file to understand which file encoding and character encoding is used here to that you don't have problems with umlauts and special characters and Chinese symbols and so on. Here's a question in the chat. Is there a semantic difference between XML, YAML, JSON, BSON? Are there constructs you can express in one but not the other? That's a very good question. Let me keep it here and we answer this question in the very end when we talked about XML, YAML, and JSON. It's too early now, but it's a good question. We call it powerfulness. The powerfulness of a language is what can you express in that language. I think there's the joke or the fact that Inuits or people living at the North Pole or South Pole have 100 different words for snow, and we just say snow. So their language is, regarding to the topic snow, more powerful than our language. and this is the case also for programming languages. There we talk about Turing completeness. So a programming language is Turing complete when, I don't know the definition, but all the programming languages that we know are Turing complete. This means you cannot develop an algorithm in Python that you cannot develop in Java also. They have the same power. But here we take a look at in the end whether it's powerful or not. The powerfulness is the same. YAML. I have here a nice website, try out at. Okay, actually you cannot try out YAML. YAML is a format and like CSV, but here you have flexibility. So we have one dictionary here. A dictionary, you know, from programming languages like Python, a dictionary is a set of key value pairs. In other programming language, you would call it an associative array or a map. So a list of key value pairs. Actually a set of key value pairs, because the order does not matter. So we have product ID, description, price, categories, and manufacturer, and available, and size. These are the keys of the dictionary. And then the values are 17, chocolate bar, 89 cents, an array, and another dictionary nested in the value of the key manufacturer. So this is very powerful, and the people from YAML say this is sufficient for everything. You can model everything with 3 data types. Scalars, so that's simply an atomic value, one number or one string or one boolean or a null. So that's a scalar, an atomic value. The second data type is list. Where do we have lists? Here. And dictionaries. And indentation is very important in YAML. So if we would not indent these 2 rows here, then company and country would not be an entry for the manufacturer's array. No, for the manufacturer's dictionary, sorry, but it would be an entry of the main dictionary here. So indentation is very important at YAML. And you can go to this website and write YAML here, and it simply shows you if it's valid or not. Cannot start at line 6. Yeah, maybe this is because I used here crazy tab characters. Maybe I use 2 spaces. Spaces are often the better idea than using tabs. So again, go. This is a valid YAML. And if I would say country USA without indentation, then this is also a valid YAML. Where is it? Ah, here, country USA. So you see it orders my my keys alphabetically, and now country is a key value pair of my main document here, and before it was a key value pair in the subdocument manufacturer. So I say document because that's how you would call it at JSON. One question in the chat: why did true become true? Good question. Let me remove this characters here. Maybe because of the comma. Yeah, now it's not the string true. I have a mistake here. In my slides, I write true, comma, and this means it is not a Boolean true, but it is a string with 5 characters, TRUE, comma. So I have to fix this to really have a Boolean here. So it is a valid document, but I want a Boolean here, so this is better. So now again replace the tab characters. Okay, and now true is true. Yeah, that's the problem when you are so flexible. The people from YAML say you don't have to write chocolate bars in double quotes. It's okay, it's clear that it is a string because it's on the right side of the colon, and it is automatically trimmed, so this does not belong to the string. But then errors like this can occur. It was not a mistake to make a comma here. It just now means that this is a string that is ended by a comma. Thank you for this hint. So, question, frage.de with double A. What is the type of manufacturer? In the first exercise sheet that I will upload today in a few hours, you will try out YAML, XML, and JSON in a programming language of your choice. And of course, you do not need to manually develop a parser. There are libraries for all that. You Google YAML Python, and then you find a library that you can use in Python. Open this YAML file for key value in the content.items and iterate over the items in the dictionary. So you have libraries for XML parsing, JSON parsing, and YAML, and also CSVs. Working with CSVs without such a library is not funny, because you have to care about the things. Oh, what happens when a comma is required within the column value? Then you have to use the delimiter characters. There are libraries which read and write CSV files. So search for these libraries when you are solving the first exercise on the first exercise sheet. Okay, I give you the answer for this manufacturer. It is a dictionary, of course. Why did you say Scala or list? Scala means one value. So the opposite of Scala is complex. There are simple values, Scala values, and complex values. And complex means either a list, so just this and that and that and that and that. Lists are ordered, and lists have again scalas or dictionaries or lists. Or another non-scalar is a dictionary. And dictionary is of course right. This is a dictionary. Okay, now XML. The big picture behind XML is a tree. So XML is a tree structure. Trees have nodes. Nodes have children. And a tree has a root. So on the very top of each XML document, there is the root node. It has the type document. An XML tree consists of nodes, and there are node types. One node type is called document. That's always the root. Elements. In this example here, we have one element called products. And we have a processing instruction. They are not so important, but yeah, they belong to the 1, 2, 3, 4, 5, 6 node types. Processing instructions are, for example, this here. This is an indicator for the machine that processes the XML document to understand it. What's the XML version, what's the encoding, and so on. So actually we have here two child nodes of the document. One's the processing instruction, this XML and so on. And then we have an element called products. And in this element node, it has two child nodes, product and another product. Two child nodes, element 1, element 2, and the child nodes again have the type element. Again, look at the picture here. This element product has an attribute. The ID is 17. So attributes are also node types. Attributes have values. So the attribute name is ID and the attribute value is 92 or 17. And this product element has another child that is an element description and an element price, and both have again a child, and this is of type text. And here's a comment node. So let me try to write everything down, at least for this one child here. So it has an attribute, the ID is 17. It has an element, description. It has another element, price, and it has a comment. For this attribute, so basically only elements have children and document. So document and element have children. Processing instruction, attributes, these are leaves. There we are finished. But here for this element we have a child text, and here we have a child text. And that's now, when I would continue with this product element as well, that is our tree of the XML document on this slide. Why does this work? Product ID 17, chocolate bar, price, without describing what chocolate bar is? That's a very good question. That was one slide before. or many slides before here, product ID 17, chocolate bar, price. Let me write it is valid. It is well formed. So it is a well formed XML document. So can I vanish this away, or I can do it in a different way. No. So come on. No. No problem. So again, we start with the document. So we start with document node. Then we have one element called product. So that's the element name or the tag name. Then we have an attribute E, ID. Then we have text. Then we have an element price. And then this element price has a text child. So that's our document now. It's the microphone changed. So it's better now. Sorry, sorry. Yeah. So this is the answer. Why does this work? It works because of mixed content. Mixed content means an element has text and sub-elements. We know this from HTML as well. So let's again look at here. No. One example. Here, this code element has a child B and then text and then again child. So this is a very stupid example, but you can mix it. It is actually called mixed content. Let me use this XML file here, and I have an XML database that is called BaseX. So this is BaseX. I have here the document. BaseX is a free software. They call it BaseX is a XML database, and actually in the list that we had last time under DB engines, BaseX. BaseX is a native XML database, and they are on rank 125. So VaultDB is something that I know they are less important than BaseX. So yeah, we had this list last time, Oracle, MySQL, they are on the top, but you see BaseX is not dead. Nothing is dead. So what can we do here? We can write an XML document And when we have an error here, for example, we do not close the price. So here price currency is euro and we do not close the price, then it says here element has to be ended. So, and I have to write price in the same way as here. We come to this tool later, but one thing I wanted to show you is showing you the tree. Why can't I? Here. Here are my products. So, and it shows us the tree like I wrote on the blackboard here. Products.xml, that's the document, or actually this is a file. Then we have the products element, product, description, price. Then here's the comment, to do, increase price. Here the text, here the text. So the attributes are not displayed here. So we don't have the attribute here, but you see the tree. It is visualized here. And the tool can only visualize the tree when you have a well-formed XML document, that's clear. And you can only write queries to an XML document when it's a well-formed document. So did I say valid? No, well-formed. So I come to these terms in a minute. Some rules. So for attributes, document and so on, this is not so important, but the most complex elements are element nodes. An element starts with this smaller than character, greater than character, these angle brackets here, and yeah, you have to close them. They have an opening tag, this is an opening tag, and a closing tag is using the slash here. So, and within the opening tag and the closing tag, you have the children. In this case here, there's one child, a text node 0.89. When you don't have any children, you can write powerfulness and immediately close powerfulness again. So this is valid. This is well formed. You open something and without having any children, you close it again. That's okay. But there's an abbreviation for that, writing the slash here. So this is just syntactic sugar for this. So abbreviation for empty elements. Empty means no children, no text, no elements within this element. And each element can have a set of attributes. I write set here italic because it's important. What does it mean that it is a set? Why do I write set? Why is it important? Write in the chat what the consequence is that we have a set of attributes and not a list of attributes. When I say set, everything is clear, because absolutely right, the order does not matter. Attributes are not ordered. When you have an element with 5 attributes, you cannot say give me the first attribute, then the second one, then the third one. Attributes have names. So you can say give me the attribute, the value of the attribute ID. They don't have an order. And unique attributes, exactly. So the names are unique. When the name is already taken, you cannot use it again. So our XML document, why do I use the notepad? I have here, can I increase the size maybe of the font? Options, font, better. Okay. Price currency is euro, and again currency is US dollar. It shows me an error here. Attribute currency is already taken in the element price, so it's you cannot use the same attribute multiple times. So I can say here price class is expensive. So that is possible, but this does not mean this is the first attribute and this is the second one. No, they are not ordered. So like the elements in the YAML dictionary, they are not ordered here. So sets are unordered and do not have duplicates. So, and children are a sequence of nested elements. So a sequence is ordered, and a sequence can have duplicates. So our element products has two children with the same name, and here we have an order. I can later say with using xquery or so, I want to have the product, the first product, and this is the second product. So here is an order. The order matters. Yeah, same as for HTML. Of course the order matters. If I would write modern database concepts here and the semi-structured data behind that, the document looks different than in the other way around. So the order of elements of course matters, but the order of attributes does not matter. And the same for XML. And it is possible to mix elements and text. Here is text, and this is fine. This is okay. This picture here, this visualization, is generated when I load the content of an XML file as a database. So I can say open, so I drop my database, yes. Do you want to create a new one? Yes. Create a database using this XML file, and now it parses the file. It would show an error when it would not be a well-formed file, and now I have my my here is text, and this is fine as a child element of product. So when you use this tool, don't wonder that it does not immediately update. You have to load the file as a database. Okay, text is something like this. Elements are again sub-elements, and mixed content means an element has text and elements, and you can mix this as you want. You can say text and then an element, and then again text and then an element, and so on. Are there more questions about the XML syntax? Okay. I used the word well-formedness already. Well-formed means the document follows the rules of the language. So when every opening tag is closed and when every quote of an attribute again is closed, then the XML document is well formed. It just follows the rules of XML. So if it is not well formed, you cannot do a lot with an XML document. It is not possible to read it. In this tool we had here with the YAML lint, it says valid YAML. But actually it is not a valid YAML. It is a well-formed YAML. It follows the rules of YAML. Yeah. Valid means a document matches a given schema. So we said, why do we need a schema? A schema is something we need in SQL. Create table, the columns are product ID, description, price, manufacturer. And here we don't need a schema. But it is possible to define a schema. Without any schema, chaotic things and crazy things can occur. That's why in XML and also in JSON, people introduced schema languages. This is a language where you can describe how an XML or JSON document should look like. And then you can say to a valid XML document, does it match that schema? Yes or no? One question in the chat. Where can I write it? So well-formed is syntactically correct and valid is semantically correct. Exactly. Yeah, that's exactly the case. So when there are syntax errors, the document is not well-formed. The XML parser will fail during the parsing process. A parser always has a grammar. Bacchus, Nauer form, grammar, and so on. Grammar rules everything that is opened is closed again and blah, blah, blah. And when the document does not follow the grammar, it is not a well-formed document. It is not syntactically correct. And valid is semantically correct. So what the users want, and the XML standard does not know what the user wants. Maybe the user wants product something like this. So this is a well-formed document. You can query it, you can import it into an XML database, you can generate such a tree. It is well-formed, but it is not valid with respect to that DTD schema here. DTD is a very simple schema language for XML. Document type definition. Nobody uses it, but I show it to you because it's so simple. You just say, when an element with that name occurs, it is allowed that it has the following structure. So whenever your document has a products element, it can contain arbitrary many product element as its child. It is not allowed to have other children here. Star means arbitrary many. There's also a plus, which means at least one. There's a question mark, which means it's optional. So whenever we have a product element and the order is important, the children must be description, then price, and then sold out, but sold out is optional. Then we have an attribute list, product, has an attribute ID, which has the type CData. Basically, there's only one data type in DTD. It is called CData. It means string, write anything in the attribute. And yeah, there's another attribute type called ID, which means no duplicate values, and ID ref, only values that appear somewhere in an ID field, but that's not so important for now. It's just very simple. The attribute ID is required. So a document would be invalid if there would be a product element that does not have an ID attribute. And a document would be invalid if there's a product element that does not have a description or a price, or 2 times a sold out, or an hello element, or a text element, a mixed content. So this one here, would not be a valid document. Not because products does not appear here, that's okay. But this mixed content is not allowed in this DTD. And I did not find out how to make a DTD for mixed content. So I found something in the internet, but it did not work with the BaseX program. Well-formed is always also valid, right? No. You cannot check for validity when a document is not well-formed. So these are all XML documents. These ones are well-formed. And when it is well-formed, then it can be valid. But it cannot be valid and not well-formed, because the schema checker cannot check a non-well-formed document. So it first has to be well-formed, and then it can check, does it match a schema? So, and this is one way how to define a schema. You do not have to learn how to write DTDs. I just want to show you that this is a language to understand define a schema for XML documents, just to specify how a document should look like, so that we can say this document is valid or not. And another language for defining schema is XSD. It's also called XML schema. That's the standard. So now in the chat, write every difference between DTD and XSD that you see. Just look at this document. Remember this document from the DTD here, or I can write it here. So give me some differences in powerfulness and general differences, and we will talk about them. Very good point. XSD is well-formed XML. DTD is not XML. So DTD was first, and then the people said, when we create a new schema language, this schema definition, XML schema definition, has to be again in XML. So this makes it possible for checking whether a schema definition is valid with respect to the schema XML schema. So there is an XSD which describes how XSD should look like. So a meta schema. So more differences. XSD is XML and kind of mimics the tree structure the actual document will have in the end. Yeah, it can be seen as an archetype, so as an example of the documents later. So later we will nest product elements in products elements, and we will nest descriptions into product, and this is already nested in the schema. Yeah, very good. More differences. So these two differences that we already had, that this is XML and this looks closer to the nesting of the target document, is just optical. But what's about powerfulness? One comment in the chat: elements can be extended by metadata, for example the type of text element. Yeah, type is a very good keyword. In DTD we have only C data, this is a string that you write in attributes, and PC data, that is a string that you write into text nodes, so between an opening and closing element. Parsed character data and character data. Here we have data types. They are predefined data types. So XS is always something that belongs to the XML schema standard. So there's a data type decimal, there's a data type XS string, there's a data type integer here, and so on, Boolean. And you can write your own data types. You can you can extend existing data types and so on. So types are possible in XSD. Data types are not possible. So here we say the ID of a product must be a number. That was not possible in the DTD. In the DTD, we could write anything into an ID. XSD can specify occurrence requirements for elements and not just star, plus, and question marks. Exactly. Here we can say min occurs 7. Okay, in a DTD, let's say we have an element products, and we would say minimum 7 product elements would need to be here. There's a trick: product 2, 4, 6, 7, and the 7th one is with a plus, so optionally more. But this is not nice. And this is this is not nice. So here you say we have at minimum no sold out. So the standard is min occurs 1, max occurs 1, but we say sold out is an optional element within a product. So min occurs 0. And when I have my XML database here, so database open and manage, no, the best way is always to drop the database and load it from an XML file. So I have the XML file here. I can write xqueries here, and xquery will come in a minute. For example, give me all prices. No, what I want now is to check whether this document is valid with respect to this DTD. And I have this on the slide notes. So for document open products, return validate DTD, and then the file path to the DTD. So the answer is yeah. So when BaseX shows you something like this, so not an error, then this is valid. When I say there have to be at least 3 products, product, and at least 1 more product, then it says validation failed. the content of element type products is not complete. It must match product plus. So when I change this to at least one product, then it fulfills the schema. So we can check for validity with this BaseX tool with such a command here. I write it on the slides. It's on the next slide. Save, play, and now it's fine again. And the same when I change the XML document, here I say the ID is required and I remove the ID. It would say now it is valid because I again have to close the database, drop, and load it again from the file, because it does not live monitor the file. I have to import the file into the database. It is internally then stored as a tree in an optimized format and not like here as a text document. So now it is loaded again. When I check it for validity again, it would say validation failed, attribute ID is required, and it has to be present in the product element. So I have to add ID equals something, and then I again load the database, and it's there. Check for validity. Okay. And the same for XSDs. I have here the XML schema that I have on the slides, and there you can say validate XSD. I stored the three documents, the XML, the XSD, and the DTD on the files in a folder, and it shows, looks good. Yeah. And again, when I say something like the sold out has to be there, it is not optional, then it gives an error. Content of the element products is not complete. Sold out is as expected. It must be there. So this is then a validity check regarding this XML schema definition. Okay. On this slide you see the command, and you see in the notes of this slide how to check for validity with XSD. So I just wanted to show you this is not something you have to learn in detail. I will not say write an XSD schema for the which matches the following which makes the following XML document valid, or please convert this DTD into XSD or something. This is not extremely important. You just have to know that there are schema formats. What are they used for checking validity, and that's it. So you have seen them now. That's okay. Yeah, now I want to come to two query languages, and then we will end the lecture of today. Next week we continue with JSON. For XML I want to introduce you XPath and XQuery. XPath is very simple because the data model is a list of nodes. An XPath expression gets as an input a list of nodes, for example an XML document, and it produces a list of nodes. And nodes, you all know, elements, attributes, text. The other nodes are not so important. The node types, processing instructions, comments, and so on. And what you do is you use XPath steps to traverse through the document. So you traverse, by default you traverse to the child document, and then to the child of the child, and then to the child of the child of the child. But you can also traverse in a different direction. The axis defines the direction of traversal, and the default direction is child. So you go into a child, and then you test that child if it has a given name. So you go into this child. Does it have the name description? Yes. Then you go in the next child, and here you don't test for a name test, but for a type test. So is it a text? And if yes, then this is the result. Another important axis, so there are many axes. You can go upward, downward, to a sibling, and so on. The most important one is child, so go one step deeper. Then parent, you can write dot dot instead of parent, colon colon, and then the name of the parent. And descendant or self means the node itself in which we are currently in, or a child of a child, or a child of a child of a child, and so on. So this is very convenient to just search for a specific node without navigating directly step by step to that node. So descendant or self product means we go into the product node. We traverse, so our tree is here. We traverse until we find product nodes. So we are here, and then descendant or self. No, this does not have the name product. This also does not have the name product. This has the name product. So here we are. So when I have the path expression / product, it gives me as a result two nodes. This node here, product ID 17 and product ID 29. This is a short form for /descendant or self : product. So descendant or self : product. Yeah. Instead of writing descendant or self, you can just write // When we say /, we are at the root. So this is the full document. And basically, this is not the root. This is the first child of the document node. So this gives us the document node. Products. The result looks exactly the same, but only for us. For us, this here is looking the same as this, but this gives us the document node with all its contents, and this is the child of the document node with this element. And then we can go into product. And for a product, we can say, I want the first one. And it gives you this. Or the second one. So elements are ordered. Or we can say those which have a description where the text equals chocolate bar. So a predicate. Or where the text is not equal to chocolate bar. So within these predicates, we again use a path expression, but this one does not start at the root node, it starts at the current context node. And when we want to check for attributes, we use the add symbol, so add AD equals 29, finds this product, and ID equals 17 is this product. So add ID is a short form for go into the axis attribute which has the name ID. So, but we always write an add symbol here. So we have step for step navigating through what we want. Each step consists of an axis. The default axis is a child. And within each step we check either for a name or we say all names. So independent of what node it is, I want everything. For example, slash products, product 17 slash star finds this node, description and price. And optional predicates can be written into box brackets. So testing with and or and not and so on, whether this node should be in the result or should be for further traversal or not. If it fulfills the predicate, then we continue here, otherwise this node is not considered. Okay, and this is the long form for this, descendant or self, blah blah blah. These XPath expressions are similar to JSON path expressions, which we look at next week. And one last slide of another language. What I want to tell you here in this language are flower expressions. The idea was to be similar to SQL. So you see things like a where clause, there's also the order by clause, but they also introduced new clauses. For example, the let clause lets you introduce a variable. So for is used for iterating over a sequence of nodes that is found by this expression here, and this expression is an XPath expression. So you use XPath within XQuery. This XPath expression is just opening the database. It's a let clause. So let and for can be used multiple times and in any order. So we say document is the whole database that we open here, the XML document. Then we iterate over the product elements within that document. We call them P, and then we filter out those which do not fulfill this predicate P/price greater than 1. These are those which we do not want. So we only want expensive products, and then XQuery gives us the possibility to define how the output should look like. So let me copy this here and use it in our tool. Dishwasher tabs. I want just from the product, which we call P, the description and the text. So the for corresponds to the from clause in SQL, and the return corresponds to the select clause in SQL. And I can also say, okay, I don't want the description / text, but description. Then we have the whole element here. Or I say return hello and hello again closing. So I can introduce new tags here, but this is not something we want. So when we want expressions, we have to write them in curly brackets. So we can simply define how the output should be built. And again, you should not learn how to write XQuery expressions. This is not required for the exam. So I just want that you see that they exist and how they work. You iterate over a set of nodes, check whether a predicate is true or false, use maybe an order by, and then define how the output should look like. One last slide for today. This is a more complex one. I want an expensive products element, and this is filled with the result of this XQuery. So I find the same as before, but now more complex things. For example, I introduce a variable price, which uses a switch case statement to check whether the currency is euro or dollar, and if it is euro, it takes the times price, the price times 1.19, and otherwise just the original price. So it makes some conversions here, and in the return clause I again say how the result should look like. So the price is now as an attribute here. Yeah, that's it for today. There was one other question in the chat. Is XML Turing complete? Looks like it from the given language constructs. Actually, yes, XQuery is Turing complete. Even SQL is Turing complete. I don't know how this works, but it is. Yeah. And to the other question, is there a semantic difference between these languages? Let's move this to next week when we talk about JSON. We are finished for today. Do you have more questions about XML? You should now know how an XML looks like, what an element is, what an attribute is, what well-formedness means, what validity means, what a schema is. And that becomes important when we talk about other concepts in this lecture later. Okay, when there are no questions, then thank you very much and see us on Friday. On Friday there will be exercises. I will write all details to the course today. So yes, I will write you an email, an announcement from the course with more details about the exercises on Friday. Exercise on Friday, and I upload a PDF document, an exercise sheet today. Okay. Yes, there will be exercises. I write you an email today and upload the sheet today. What exactly does the let keyword be? You just introduce a new variable. Basically, let is not necessary. So instead of introducing a variable price, you could also copy paste this here on the place where it is needed, and here. So you introduce a new variable that makes it easier for you, especially when you need it multiple times. Can I skip the exercise? Of course, everything is optional. It's just for you. So there's no requirement so that I say you are only allowed to do the exam when you have attended the lectures and exercises and points. No, there's nothing. Everybody is allowed to do the exam. It's just for you to improve your experience with the concepts that we learn in this lecture and the technologies that we learn. Okay. And I wrote on the first chapter that there will be 12 exercise sheets. I'm not sure whether there will be 10 or 11 or 12, so maybe 12 does not fit. We will see. So see you on Friday in the exercise or next week Tuesday in the lecture. Goodbye.